Hi, this video is a continuation video of Matlab and Python codes that I uploaded earlier about this paper. So in this set of Matlab and Python codes that I'm uploading, by using them you can generate the recent results in the manuscript, such as figure 11 and figure 8, result for large network sizes, and multi-path results. In this set of upload, I'm not uploading all the algorithms, I'm uploading only random forest Python codes and linear II init iteration, initialization iteration, rate metric, beam selection MATLAB codes. For instance, I'm not uploading this one. So the framework of the codes are similar as earlier here, but it is the codes are cluttered. The names of the files, the comments, they are not organized. So again, we have three steps. First, we run the beam selection algorithm, which exists in this folder code01. So if we do not have generated the channels earlier, the channels are generated by using the codes under this folder. When the beam selection algorithm is done, then we go to AI, artificial intelligence folder, and there are two codes here, Python and Matlab. So as a next step, we run the Python codes to train our machine learning algorithm. And as the last step, we run our Matlab codes here. So this Matlab code is to see how close this machine learning algorithm could get results to the original conventional beam selection algorithm. So as usual, we have this network list Excel file, which is suggested to be opened by library sheet, not Microsoft Excel sheet. So what we want to do is we want to test 1:3 ratio of training and test cases. This is the network size with transmit power, number of initialization iterations. So for beam selection algorithm, we choose 1, 1. I'm not talking about why this is 1, 2, 3, 4, 6. You can find the explanation in the first video. So as an example, we can run maybe 30 to 10 because they have not been generated before. So when we run our beam selection algorithm, it will execute those two Monte Carlo cases. For the first one, this is our sum rate. For the second one, this is our sum rate. And the results are output in this Excel sheet. So these are Monte Carlo 10 results, and these are Monte Carlo 30 results. So we want to train our machine learning algorithm. So we need to go here and change this one only to AI version 10. This means we want to run random forest algorithm. So it's enough to change the training line only, assuming we always input 1:3 ratio of training and test instances. So then we just run this machine learning algorithm. So it only prints out the number of the accuracy percentage, but and it is output here again on an Excel sheet. Sorry, this is for beam selection. Here's our Excel file for 30 to 10. Here are the results. Accuracy is over here, and as you see, these cells are empty, and these cells will be filled by this Matlab code here. So the idea here is you can fill in all the cases you want to test here, and then in the end you can run that Matlab code, and that Matlab code will start filling in from the first line until the end. So you need to be careful. It might overwrite your first line in case it is already filled here. So now we can run our final Matlab file. Sorry, now we need to change again this one, the training line, to 1, and this one to 0, because we don't want that Matlab code to execute the second line. If you follow the first video, you will understand the reason. Basically, this /1 tells which numbers should be executed. So now we can execute our final step. And as you see, these empty cells are filled. So here you see by chance these numbers are like both 15, but it is irrelevant. So this is the original sum rate, which is achieved by the beam selection algorithm, and this is the sum rate achieved by the machine learning algorithm. These are all from the first set of codes, so we don't need to explain. And probably you will have folder location issues when you execute these codes. They are very easy to fix. You just need to go to the problematic line in the codes and change the location folders, folder locations, such as this one, and many other places. You might need to change the folder locations. And there are some other sub issues. For instance, these files folders need to be created already, but if there's a temp folder here already, it won't work. So these are minor issues. I mean, just I didn't make it automated. I believe you can fix those minor folder location, existing folder, not existing folder issues. Probably you will only face folder location issues, nothing else. Thank you. In addition, I would like to briefly talk about the channel generation file. Here you see some lines that I used in earlier versions, which I didn't delete. Here some lines that I used in earlier versions, but in the recent version I used this for multipath. I want to talk briefly about feature vectors for machine learning training. So this channel generation file creates a lot of feature vectors and loads them in a matrix. But for training, we use only some of them. So you can choose which features you want to use. And although again they are generated and loaded in a matrix, some of them are used, and you can choose which ones to be used in the machine learning algorithm here. So it says select as a training only from 1 to 3 times the first this many columns. You use it. That is basically use this one, and this one for training. So you can edit the lines in this file and the line in this file to choose which machine learning algorithms, which features to use for the machine learning algorithm. Here you see pieces of lines that I deleted for large network sizes. If you uncomment this, it will not run, the algorithm will not run for large network sizes. I haven't deleted the commented lines. You can delete them as you like.